Skyscrapers and stability. Lesson objective. By the end of this lesson, students will understand the engineering behind skyscrapers, learn about forces acting on tall buildings and how engineers ensure stability, explore materials and construction techniques used in skyscraper design, discover real-world examples of skyscraper innovations and challenges. Why do we build skyscrapers? Definition: a skyscraper is a very tall building, typically 40+ floors, designed for residential, commercial, or office use. Examples: Burj Khalifa, Dubai; Shanghai Tower, China; Empire State Building, USA. Skyscrapers save space in crowded cities and allow more people to live and work in urban areas. Forces acting on skyscrapers. Gravity pulls everything downwards. Skyscrapers must resist this force to remain standing. Wind force: high winds can push against buildings, causing swaying. Earthquakes: ground movements can shake buildings, making them unstable. Load: weight, people, furniture, and equipment add weight to the structure. Vibrations: external factors like construction or even footsteps can create movements. How engineers solve these challenges. Strong foundations: skyscrapers have deep foundations that spread the weight evenly. Wind resistance: special shapes, curved, twisted, or tapered, reduce wind impact. Earthquake safety: flexible materials and shock-absorbing technology help withstand shaking. How skyscrapers stay standing. Foundations, the key to stability. Skyscrapers are built on deep foundations that extend into solid rock or strong soil. Example: the Burj Khalifa has a 50-meter deep foundation. Building materials. Steel: strong, lightweight, and flexible, used in most skyscrapers. Concrete provides strength and durability, used in core structures. Glass, used for windows and walls to reduce weight and improve energy efficiency. Structural designs for stability. Rigid core system: a central core, made of concrete, holds elevators and stairs, acting as a backbone. Tube structure: the outer frame acts like a hollow tube, resisting wind and earthquake forces. Brace frame: diagonal supports help distribute forces evenly. Innovations in skyscraper design. Twisting towers: example, the Shanghai Tower twists to reduce wind pressure. Damping systems: skyscrapers use mass dampers, heavy weights at the top, to reduce swaying. Example: Taipei 101, Taiwan, has a 660-ton damper to absorb movement. Self-healing concrete: future skyscrapers may repair their own cracks using bacteria-activated materials. Real-world challenges in skyscraper engineering. Cost: skyscrapers require billions of dollars to build and maintain. Safety: fireproof materials and emergency evacuation plans are essential. Environmental impact: engineers are working on eco-friendly skyscrapers with solar panels and green walls.
Please like, share, and subscribe to the channel for more future educational videos.